Good morning, dear students. Yes, yes. So in the previous class, what we were discussing, the half-life of the reaction, right? So we have discussed the half-life of the reaction. That is T half of first order and T half of so the half-life period for first order reaction and half-life period for zero order reaction. So based on that, we have solved some of the problems. Okay, so we have solved some problems. So we have left with two more problems. Okay, so take this as homework. Okay, so you can solve it. So you can solve it later. Okay. Or shall I give it at the end of the class? So let me give it at the end of the class. Okay. So two problems are there. So you can take it as homework later. Okay. So let us solve it in the next class. Fine. So let us start with the next concept. So the next concept we are going to discuss about the pseudo first order reactions. Okay. Now we have seen what are zero order reaction, what is a first order reaction. Okay, so the next is what do you mean by a pseudo first order reaction? Okay. Just a sec. Yes. Okay, so what do you mean by pseudo first order reaction or pseudo unimolecular reaction? Okay, pseudo first order reaction, or it is also called as a pseudo first unimolecular reaction. So what is the definition of this? Important, very important, ask for 2 marks. What the question will be, the question is asked as what are pseudo first order reaction? Give example. So 1 mark for the definition, 1 mark for the example. Okay. So what are pseudo first order reaction or what are pseudo unimolecular reaction? Give an example. So like this, the question is asked for 2 marks. Okay. So this is a 2 mark question. So what should be the answer? What you have to write? The definition, a reaction in which the molecularity is 2. What do you mean by molecularity? We have seen what is molecularity means what? How many number of reacting species are involved, right? So depending upon the reacting species, how much they are involved. Okay, so that decides your molecularity. Now, so a reaction in which molecularity is 2 or more, but the order is 1. It is called as pseudo first order reaction. Now you can see. Okay, so we'll see the examples also. So understand first the definition. So a reaction in which the molecularity is 2. Molecularity means how many number of molecules are involved in the reacting species. So here you can see there are more than one. Okay, so here it is either, so there are 2 molecules are involved. So the reacting species involved in the reaction are 2. Okay, so a reaction in which the molecularity is 2 or more. It can be more also, but the order is 1. Okay, the order is given as 1. Then such a reaction are called as pseudo first order reaction. What do you mean by, what is the meaning of pseudo? Pseudo means false. Okay, pseudo means false. Okay, what is the meaning of pseudo means false? It is a first order reaction, but it behaves like a first order reaction. It is not a first order reaction. It behaves like a first order reaction. The molecularity of the reaction is 2, but the order is 1. It acts as a first order reaction. Okay, so it is called as pseudo unimolecular reaction. So what is the definition? One more time, I'll repeat. A reaction in which molecularity is 2 or more, but order is 1 is called as pseudo first order reaction. It is called as what? Pseudo first order reaction. So what is an example? So there are two important examples. Okay, very important examples. So you can study both these examples. Okay, whenever the question is asked. what is pseudo first order reaction, give an example. So any one of the example you can write. Okay, so what is the first example? Acid hydrolysis of this what acid hydrolysis of your you can take this one. Okay, acid hydrolysis of methyl acetate. Okay, acid hydrolysis of methyl acetate. So let us see first this one. Okay, so acid hydrolysis. Okay, acid hydrolysis. Hydrolysis means what? So we are adding water in the okay, in the presence of acid, in the presence of acid. So that is meaning of acid hydrolysis. So methyl acetate. Okay, methyl acetate. So CH3 COO C2H5. Okay, so this is ethyl acetate. Okay, this is a ethyl acetate. So what? So this is a ethyl acetate. Ethyl acetate. So this is a acid hydrolysis of ethyl acetate. Okay. So ethyl acetate, when it undergoes hydrolysis in the presence of acid, you get acetic acid, and you get ethanol. Okay. So whenever, so what is ethyl acetate? What type of compound it is? Can anyone tell me what type of compound is ethyl acetate? In which, what functional group it has? Yes, ethyl acetate. What is the functional group? Can anyone tell me? What is the functional group in the ethyl acetate? Yes, students, try. So, by seeing this, what you will say that it is a alcohol. By seeing this particular compound, what you will say it is a acid. So, what is this? It comes under which class of functional group? Yes. It comes under which class of functional group? No, no, baby, no. Ethyl acetate. Okay, let me write it. CH3, C double bond O. Okay, C2H5. Can you tell me what is this bond? What is this? No. Yes, others try. What is this first to tell me? This for particular, what is this? Is it a ketone? No. What is this? Yes, this is a ether. Fine. This is a ether. What is this? This is a ether. Yes. Okay. So this one is ether. ROR dash is a ether. Whenever you have oxygen linkage in between two alkyl or two aryl groups, then it gives rise to ether. What is this now? Yes. Others also can try. What is this? We have. Okay. What is this? This is a ketone. This is a ketone. Okay. This, yes. This one is a aldehyde. Okay, this one is a aldehyde. Okay, good. So this is a ketone. This is,
Alcohol.
yes, it is a alcohol. Very good. And when you have a aromatic ring attached to OH group, it is a, Yes, phenol. Very good. Okay. So now what is this? So you have a C double bond O linkage. So this is a ester. Okay, this is called as a ester. We have seen esterification reaction. You forgot? Yes, in last class, alcohol, phenols, and ethers, we have seen esterification reactions, right? How to prepare esters. Sorry, from esters, how we get alcohols and acid, right? We have seen esterification reaction. So esterification reactions are what reaction? Esters undergo acid hydrolysis to give you acetic acid and alcohol. So these reactions we have seen. Just see, okay, if you have your notes written down, so you can check in that. So esters, so this is a ethyl acetate. So ethyl acetate is undergoing a acid hydrolysis to give you acetic acid. Okay, that is one acid and one alcohol, that is a ethanol. Okay, so we are studying the acid hydrolysis of ethyl acetate. So ester is there and it will give you a acid and a alcohol. So what you can see, it is a bimolecular. Okay, there are two molecules involved. So bimolecular reaction, and theoretically, okay, the rate equation, it is given as rate is equals to, okay, K into the this concentration of ethyl acetate and concentration of water. So theoretically, so this is a bimolecular reaction. Bimolecular reaction, but theoretically, how the rate is given? Rate is given as K is equals to rate constant is equals to, okay, CH3, COO, C2H5. So it depends on concentration of both. It depends on concentration of ester also, and it depends on concentration of water also. But when you consider the order, okay, so you what you can see, the order, it appears to be two. Order is it appears to be two, but water here, okay, it is taken in large excess. It is taken in more amount. Water, okay, the water which is taken, it is taken in a large uh, amount as compared to your ester. As compared to ester, the water what we have taken in the reaction, it is in large amount. Okay, so what will happen? The concentration will does not change. Okay, so the concentration of water, it will does not change much during the reaction. So there is not much. It does not affect the reaction. Okay, so experimentally, what will be the rate equation? So experimentally, so this is theoretically. Theoretically, there are two molecules involved in the reaction. So order appears to be two. Okay, but water is taken in large excess, but it does not alter any the reaction. So experimentally, rate is depends on the concentration of only ethyl acetate. Okay, so order is what? Order is 1. Okay, order is 1. Okay, so a chemical reaction, it is appearing to be higher order, but it follows a first order kinetics. So it is called as a pseudo first order reaction. Okay, it is called as what? Pseudo first order reaction. It is appearing to be two. It is appearing to be a higher order. Okay, it is appearing to be a 2. The order is, it is appears to be 2, but what it is a first order reaction. So it follows first order reaction. So these are termed to be as a pseudo first order reaction. Okay, so what are pseudo first order reaction? A reaction which appears to be a higher order but follows first order kinetics are called as pseudo first order reaction. What can be example? So you have to write acid hydrolysis of ethyl acetate and give this equation. Okay, you have to write the sentence, that is acid hydrolysis of ethyl acetate, and write the equation. Okay, please note it down. Please note down this equation and write this rate equation. Okay, so here water is what? It is constant. Hence, it is taken in large excess, but it is not altering any chemical reaction. So the rate of the reaction depends on only concentration of ethyl acetate. Thus, the order is 1. Okay, so thus the order is 1. So this was the first example. Second example is inversion of cane sugar. Inversion of cane sugar. What is cane sugar? Cane sugar is sucrose. Okay, sucrose is called as cane sugar. Okay, so sucrose C12H22. Okay, C12H22O11. Okay. So sucrose, when you take excess of water, so undergoing acid hydrolysis to give you glucose and fructose. Okay, so sucrose undergoes acid hydrolysis. Okay, and it gives you what? It gives you glucose and fructose. So again, here also you can see the reaction is a bimolecular reaction because it depends on the concentration of two molecules. The reacting species involved are how many? Two reacting species are involved. Okay, but the water concentration is more. The water concentration is more. So because the water concentration is more, so that is not altering the rate of reaction. Okay, so the rate of the reaction, it depends only on the concentration of the sucrose only. Okay, so the order appears to be a higher order, but it is a first order reaction. So pseudo unimolecular reaction or pseudo first order reaction. So what are pseudo unimolecular reactions or pseudo first order reaction? Okay, so these are the reactions which behaves as higher order, but it follows first order kinetics. Is it clear? Yes. What is pseudo first order reaction? Yes. Is it clear?
Yes, ma'am.
Okay. So next is, okay. So next we are going to discuss about the temperature dependence of rate of reaction. Okay. So next concept is temperature dependence of rate of reaction. So generally what happens, the rate of the reaction or the rate constant of the reactions will double after every 10-degree rise in temperature. Okay. So after every 10-degree rise in temperature, what will happen to the rate of reaction? The rate of reaction or the rate constant, rate of reaction or the rate constant, what happens? It goes on increasing. So at every 10-degree rise in temperature, okay, so rate of the reaction or rate constant, what happens? It doubles. It doubles. Okay, it get doubles in at every 10-degree rise in temperature. So the ratio of the rate constant of the same reaction at two temperature differing by 10 degree is called as temperature coefficient of reaction. So how the temperature coefficient is given as Kt plus 10, that is rate constant as T plus 10 degree Celsius upon rate constant at this Kt. Okay, that is, it can be given as, so I'll write it. Okay, so Kt plus 10 upon Kt. That is rate constant at T degree Celsius. Okay, that is will be equal to 2. So in general, so what will happen? A temperature increases the rate of all the reactions, exothermic as well as endothermic. So it can undergo exothermic change or it can undergo endothermic change. So every 10-degree rise in temperature, what will happen to the rate constant? Rate constant or the rate of reaction, it gets doubled. Okay, it gets doubled. Okay, so this is the temperature dependence reaction. Okay. Next, so next we are going to discuss about the Arrhenius theory or collision theory. Okay, next we are going to discuss about the Arrhenius theory or collision theory. So what is the what theory talks about? Okay, what are the points? Okay, so these are the postulates. So these are the postulates. So according to theory, so what are the postulates of collision theory? So for a reaction to occur, there must be collision between the reacting species. Now, okay, so how A plus B will give you C plus D? Yes, suppose a reaction is there. Okay, suppose a reaction is there. Okay, that is A plus B giving you C plus D. So how this C plus D you are going to get? Yes, so this is a product, right? This is a reactant. Okay, so how you are going to get product? Yes, unless and until A and B reacts. Okay, how it will react? It should collide with each other. Okay, it should collide with each other. Okay, so once the reaction, okay, so if you have if you have uh, if you have sugar in one glass, okay, if you have tea powder in one glass, milk in one glass, water in one glass, okay, will it automatically you will get tea? Yes, automatically will you get tea? No, right? You have to simultaneously do the process, right? You have to take a vessel, okay, you have to on the gas, right? You have to go on the stove, then you have to put water, put tea powder, put sugar, then after boiling, then you put milk, then only you'll get the tea. Okay, so same way, whenever a reaction is you're getting, you're proceeding with any reaction, okay, so there should be a collision. Okay, it should react. The reacting species should react. Okay, so once the reacting species will react, if they undergo collisions, then only the reaction will proceed. Okay, so this was the first postulate of collision theory, okay, which was given by Arrhenius. Okay, so it is called as Arrhenius theory or it is called as the collision theory. So this is the first point according to the postulate. Okay, then second is what? All the collisions, okay, all the collisions are not effective. So all the collisions are not effective. Only those collision between the molecules having the necessary minimum amount of energy for the reaction collides effectively and gets converted into product. Okay, now some of the suppose, okay, I have a container. Okay, I have a container. In that I have molecules. Okay, I have molecules. Now, I have added two different types of molecules. Okay, so I have added two different types of molecules. Now, some of the molecules, okay, what will happen to some of the molecules? Some of the molecules, they will react with each other. Okay, they will react with each other like this. So they will react with each other. Okay, now some so they will react with each other and the reaction will proceed. Now some of the molecules, what will happen? Unnecessary, they will go and hit the container. Okay, unnecessary, they will go and hit the container. Will it give any product? Yes. Will it give any product? No. Right. So all the collisions are not effective. So this is only, this also is going there. It is also going and colliding. Okay, it is also going and hitting the vessel. But is it giving any product? No. Right. So all the collisions are not effective. Okay, but only those collisions, only these collisions, okay, between these molecules, okay, so these are effective. So these are effective, okay, because they are having minimum amount of energy for the reaction. So they will react with each other, okay, and these molecules will have minimum amount of energy between them for the reaction, and thus they will collide effectively and they get converted into product. So these only such molecules, okay, they will collide with each other with minimum energy, and what will happen? They will form the product. Okay, so all the collisions are not effective. Only certain collisions with minimum amount of energy will react with each other and it will be converted into product. Okay, so the minimum amount of energy, that is that a reactant, okay, so this minimum amount of energy that the reactant molecule should possess in order to bring about a chemical reaction is called as threshold frequency. What it is called as? Threshold frequency. So please note down what is threshold frequency. So it is the minimum amount of energy. It is the minimum amount of energy, okay, minimum amount of energy that that reactant, okay, that reactant molecule, reactant molecule should possess in order to bring a chemical reaction. Okay, so this is a threshold frequency. So please note down. So please minimum. Okay, so I have written shortcuts. Don't use shortcuts. So what is threshold frequency? Threshold frequency THRE. Okay, THRESHOLD. So threshold frequency is what? Threshold frequency. It is the minimum amount of energy which a reactant molecule should have, okay, so that it will undergo a chemical reaction. Okay, so it is given as ET. It is given as ET. Okay, is it clear? Are these two important collision points clear? Postulates are clear? Did you understand? So for a reaction to occur, there should be collision between the reacting species. Okay. And all the collisions are not effective. Only certain collisions are effective. Okay. Between the molecules having a necessary or it is having a minimum amount of energy. Okay. So that it collides with each other and it gets, they are converted into product. Okay. Okay. Fine. So this is about your collision theory. And then what is threshold frequency? It is a minimum amount of energy that a reactant molecule should possess or it should have in order to bring a chemical reaction. So for any reacting species, now A plus B should react with each other. Okay, it should have this minimum amount of threshold frequency so that it will convert it into C plus D. So this minimum amount of energy that a reactant molecule possess in order to bring out a chemical reaction is called as a threshold frequency. What it is called as threshold frequency. Okay. Next is we are going to discuss about the activated complex. Okay. What is activation energy? What is activation energy? Important again, activation energy. So activation energy is given as EA. Okay, it is given as EA, small a. Okay, activation energy. So this is a graph of activation energy. Okay, so the activation energy is a plot of potential difference. Okay, it is a plot of potential energy, okay, versus the reaction coordinate. So this particular graph. Okay, potential energy versus reaction coordinate. So the minimum extra energy that a normal reacting molecule should require to attain the threshold frequency is called as the activation energy. So the minimum amount of energy. So the minimum amount of energy, okay, that is the extra energy that the normal reacting molecule, okay, should have to attain the threshold frequency. It is called as the activation energy. Okay. So the extra energy which is required to attain the threshold frequency. So what is activation energy given as? Activation energy is given as ET minus ER. Okay, ET means the threshold energy minus the reacting energy. Okay, so this is your from the graph. This is clear. Okay, so whatever the energy is required, suppose, okay, this is your what I'll take this particular graph. Okay, consider this particular graph. Okay, now if it is the reacting species, the energy required by the reacting species. So so this will follow a path, okay, and it will reach at certain point. Okay, so it will form what? It forms a activated complex. So this energy, okay, it is called as the activation energy. Okay, now what will be the reacting is doing? Reactant is reacting. Okay, it is reacting and it is going to form the product. So this is the product. So this is the EP. Okay, now this is a EP. Now in between, the in between, okay, so this is the minimum energy. This is the minimum energy the reactant should possess. So either in this state, what is happening? The reactant, it is in its intermediate state. Okay, it is not in reactants also, not in products also. So it is forming a intermediate, okay, in the threshold. This, so this is what? This is a minimum energy, okay, or the extra energy. What is activation energy? The minimum extra energy that a normal reacting molecule should require to attain a threshold energy is called as the activation energy. So this is about the activation energy. Okay. So let us see the effect of temperature on the rate of the reaction. Okay, how every 10-degree rise of temperature, okay, how the rate of the reaction doubles. Important, mark this question as important. So with increase in, okay, so so what happens when the with the rise of 10 degrees Celsius, the rate of reaction nearly doubles. Okay, so what is happening here? So here, so with the 10-degree rise in temperature, the rate of the reaction, how it is doubling. Okay, so the distribution of the kinetic energy among the gas molecules at two temperatures we have seen. Okay, so here what you can see, so the number of particles with kinetic energy E, okay, it is given here. So the number of particles with the kinetic energy E, okay, it is given here. So the number of particles with the kinetic energy E, so this is the number of particles versus the kinetic energy. Okay, so the fraction of molecules versus the kinetic energy. So this is a plot. So these are the two different graphs. Okay, so the distribution of this kinetic energy among the gas molecules. So this is the distribution of the number of particles of the gas molecules at two different temperature. What is the temperature? One is at 300 Kelvin, another is at 310 Kelvin. Okay, so how it is graphically represented. So what you can see from these two different graph. Okay, so from this above graph, what you can see that as the temperature increases, okay, as the temperature increases, the kinetic energy of the molecules also increases, right? So as the temperature increases, what will happen to kinetic energy of the molecule? Kinetic energy of the molecule also increases. Okay, so this is with respect to your temperature. Okay, so number of particles of energy greater than EA at 300 Kelvin. Okay, so as the kinetic energy increases, as the temperature increases, kinetic energy also increases. Okay, now so the curve is showing a higher temperature, okay, and then it gets flattened and shift towards higher energy. So first it increases and then gets flattened, okay, and then what you can see here, the number of activated molecules having energy equal to or more than threshold energy becomes almost double. Okay, it almost becomes double. So here from the graph, what you can see that at T degrees Celsius, the fraction of energy, okay, is more than activation energy and it forms a product. Okay, so the products, so this is the product form. Okay, and at T plus 10 degree means at plus 10-degree rise in temperature, you can get the products this. Okay, so what you can see that the so at your okay, so the product formed is doubled, right? What you can see that at every 10-degree rise in temperature, whatever the product formed, it is doubled. Okay, so it is doubled and the rate of the reaction also is doubled. Okay, so this is with respect to uh, your activation energy. So this is a graph. Okay, so important again for 2 marks. So all these graphs in collision theory, okay, activation energy graph, this particular graphs is very important. Okay, this is a important from exam point of view. So at every 10-degree rise in temperature, what will happen to rate of the reaction? Okay, rate of the reaction or rate constant, it also get double. Okay, it gets double. So this is with respect to your activation energy. Okay. So next is Arrhenius equation. Okay. Important. They can give you, they'll ask you to write, give the Arrhenius equation and explain the terms. Write down, write down it. Either it will be asked for 1 mark or 2 mark question. Okay. Mark it as important. So write Arrhenius equation and explain the terms. Okay. Write Arrhenius equation and explain the terms. So what is Arrhenius equation? So Arrhenius, he gave, okay, a mathematical equation between temperature and rate constant. Okay. He said what at every 10-degree rise in temperature, what will happen to the rate constant? Rate constant doubles, right? So he proposed a equation. So what was the equation? K is equals to A into E minus EA by RT. So this is your Arrhenius equation. What is K? K is the rate constant. So please write it down. What is K? K is the rate constant. Okay. Then K is the rate constant. Then A is what? K is rate constant. A is Arrhenius constant. Arrhenius constant. Okay. Then EA is what? EA is activation energy. Activation energy. Okay. The activation energy is given in joule per mole. It is given in joule per mole. Okay. Next is what? We are left with T. T is what? Temperature. And how this temperature is given? Temperature is given in Kelvin. It is given in Kelvin. Okay. R is what? R is gas constant. R is gas constant. The value is 8.314 joule per, I'll write the year, joule per mole per Kelvin. So please note it down. What is gas constant unit? Joule per mole per Kelvin. Okay. So joule per mole per Kelvin. So what is Arrhenius equation? So Arrhenius, he gave a mathematical equation between temperature and rate constant as K is equals to A into E minus EA by RT, where K is rate constant, A is Arrhenius equation, EA is activation energy in joule per mole per mole, and T is temperature in Kelvin, and R is the gas constant whose value is 8.314 joule per mole per Kelvin. So what does the rate equation tells you? Yes, by seeing the rate equation, what you can see that, okay, the rate equation, so the rate of the reaction increases, okay, with the increase in temperature. So as the temperature increases, what will happen to the rate of reaction? It also increases. Okay. So or rate of reaction increases with decrease in activation energy. Okay. So it increases with it increases with the temperature or it decreases with the activation energy. So what will happen to the rate of reaction? The rate of reaction increases. So with increase in rate of reaction, activation energy decreases. With increase in rate of reaction, temperature increases. So this is the relationship given by Arrhenius. Yes, is it clear? Yes. Okay. Fine. So this is about Arrhenius equation. So in the next class, we have some more problems based on this activation energy. Okay. Then effect of catalyst and all is there. So let us do it in the next class. So those two problems, okay, of the half-life period. So let us solve them first. Okay. So is it clear about? So in today's class, what all things we have seen is we have studied about what are pseudo first order reactions with examples. Then we have discussed about the temperature dependence of rate of reaction. Then we have discussed about Arrhenius theory, that is collisions theory postulates. Then what is the activation energy? Then what is the effect of temperature on the rate of reaction and Arrhenius equation. Is it clear? All these things are clear? Yes? Okay. Any
Ma'am.
doubts?
No, ma'am.
Okay. Fine. So let us see the remaining problems of the previous, that is a half-life. So the rate constant for first order reaction is 60 per second. How much time will it takes to reduce the initial concentration of the reactant to its 1/16th value? Okay, so this is with respect to the nth term, right? So how T of nth is given? T by n, 1 by n is equals to 2.303 by k log of 1 by 1 minus 1 by n, right? So this is with respect to the nth term. So here the nth term is the 16. So we have to find T of 1 by 16. So that is 2.303. What is the first rate constant for the first order reaction is 60. Okay, it is 60 per second. Then log of 1 by 1 by 1 by 16. Okay, solve and see how much you are getting. So T by 1 by 16 is equals to, so this is 2.303 by 60. Okay, then log of 1 divided by, so take 16 common. So if I take this 16 common, so this will be 16 ones are 16 ones are. What they have done here? Don't take common, let me see. So 1 by 1 minus 1 by 16. Okay. 1, no, this is 1 and this is 16. So if I take 16 common, 1, 16s are 16 ones are. So 16 minus 1, it is 15 by 16. Got it? Yes. So it is 16 by 15 by 16. So like this. Got it? So here, see what they have done. I'll do it here again. See here, it is 1 minus 1 by 16 it is. So 1 minus this is 1 by 1 only. So what will take? 1 and this is 1 minus and this is 1 by 16. So I'll take 16 common. So 1, 16 is 16, 16, 1 is 16. Right? So 1 into 16 is 16, 1 into 1 is 1. So 16 minus 1 is 15 by 16. So this is 1 by 15 by 16. Now, 1 by 16 by 16, if I write it, so T of 1 by 16 is equals to 2.303 by 60. Okay, log of 16 by 15. Okay, so if I do this ulta, so it will become 16 by 15. Now next step is what? T of 1 by 16 is equals to, so see what is log 16 by 15? 16 by 15. 16 by 15 is 1.02.303 by 60 log of 1.066. Okay, so what I'm going to get here? So let us find T of 1 by 16. So 2.303. So 2.303 divided by 60 is 0.038. Okay. Then into what is log of 1.066? It is 0.0277. Okay. Now just see how much you're getting. So 0.0277 into 038. How much you have got? 1.066. Okay, yes, the answer is 1.067. Actually, it will come in decimals first, then we will shift it to 0. So the answer is how much? You are getting 0.00105. Okay, so if I shift the decimal, it becomes, I am shifting the decimal 3 times. Okay, 3 to the right side. So it will be 1.05 into 10 raised to minus 3. So this is T of 116. Everybody got the same? Yes. Check your answers. Is it clear? Everybody got the same? Is it clear? The problem is clear. Okay. So this is with respect to nth term. Okay. So we have seen this also particular formula. So based on that formula, we are going to solve this type of question. Okay. One more question. One more question. A first order is 1/3 complete in 30 minutes. Calculate how much remained after 90 minutes. Okay, so a first order is 1/3 complete in 30 minutes. Calculate how much remained after 90 minutes. Okay, so we know that T of 1 by n is equals to 2.303 by k. Okay, log of 1 by 1 minus 1 by n. Okay, now here, so what they have asked? T of 1/3. So T of 1/3, first you have to find T of 1/3. So it is 2.3. Okay, into k, what is first order? It is k, we don't know. Then log of 1 by 1 minus 1 by 3. Okay, so T of 1/3 is given, that is 30 minutes. So 30 minutes is equals to 2.303, okay, by k log of what I'll do, let me shift this k this side only. Okay, so I can do like this. Yes, I can shift this here, this here. So k is equals to 2.303 by T of 1/3 log of, okay, so this will be what? 1 by 1 minus 1 by 3. So 3 common. So 1 3s are 3, 1s are 1 3s are 1 1s are. So it will be 2 by 3. Okay, so it will become 2 by 3. Is it clear? I'll clear this now. Okay, so it will be log of 2 by 3. Okay, log of 2 by 3, 1 by 2 by 3. Okay, log of 1 by 2 by 3. Is it clear? I'll clear this. Or I'll write it side here. So what is log of 1 by 1 minus 1 by 3? Okay, so it is 1 minus 1 by 3. So 3. So 1 3 is 1 za. So 3 minus 1 will 2 by 3. So log of 1 by 2 by 3. Okay. So what we'll get here? So log of 1 by 2 by 3. So in the next step, 2.303 t third is, here is, what is the value? 30 minutes. Okay, it is 30. So 30 log of 2 by 3 is 3 by 2. Find out the values now. Values. So 2.303 divided by 30 is 0. It is 0.07676. Then log of 3 by 2. 3 by 2 is 1.5. So what is log of 1.5? Log of 1.5 is 0. It is 0.176 into 0.07676. So into 0.176 into 0.07676. So I have got it as 0.0135 K, no? So it is minute. Are you getting the same? Yes. Okay. So
Yes, ma'am.
yes. Yes. Good. Very good. Okay. So we have found out the rate constant for 1/3. Okay. Now what is the next step? We have to find how much remained after 90 minutes. Okay. So one more, this is there. So we know that K is equals to 2.303 by T. So log of R naught by R, R naught by R. So here, so what is K is 0.0135. This is 2.303 by T is your 90 minutes. Then log of, we have to find how much remained after 90 minutes. So R naught is how much? So 1 by R naught. So log of 1 by R. Okay. Now here 2.0135. So if I transfer this, it will become 90 by 2.303 is equals to log of 1 by concentration of R. See how much you are getting? 0.0135 into 90 divided by 2.303. I've got it as 0.5275 is equals to log of 1 by concentration of R. So if I transfer this log this side, so it becomes anti-log. So anti-log of 0.5275 is equals to 1 by concentration of R. So anti-log, the value I am getting is 3.369, okay, is equals to 1 by R. So 1 by concentration of R is equals to 3.369. So concentration of R is equals to 1 by 3.369, which is 0.296 mole per liter. See, are you getting the same? So this is after 30, after 90 minutes. Okay, after 90 minutes, how much is remained? Okay, so this is the concentration of R. Are you getting the same? So anti-log again. So if you have not studied anti-log in the last class, okay, you have not gone through the anti-log, so please go again. So anti-log, you need to know how to find out the anti-log. So copy down the steps after anti-log. Okay. So just find out the anti-log and then get the value. Is it okay? Any doubts up to your?
No, ma'am.
Okay, fine. Okay, fine. So copy down this problem. Okay. Fine. So the remaining things we'll be discussing in tomorrow's class. Okay. Fine. Okay. So I'll be ending the session here. Let us meet in tomorrow's class. Thank you. Have a good day.